Alright, welcome back. So what to solve questions on solubility. This topic I have discussed it very well, but I have not solved the calculation aspect. So based on request, I want to solve the calculation aspect, okay? Alright, then I will also release the video, where I discuss the topic as well. So let's just do some calculations on this, okay? So the first one, it said 20 grams of water dissolve 7.6 grams of the salt. Salt at at 25 degrees Celsius, okay? What is the solubility of the salt in grams per 100 grams of water at 25 degrees Celsius? So you can see 20 grams of water dissolves 7.6 grams of salt. Okay, so 20 grams of water will dissolve 7.6 grams. So what is the mass? The mass of the salt or solute. Okay, let me write solute. The solute is what? 7.6 grams. While solvent is what? 20 grams. Okay? Now, listen up. You are dissolving 7.6 grams in 20. Okay? So, the comparison is, the solubility is in 1 gram per 100 grams. Do you understand? That is gram per 100. That is how many grams will be in 100 grams of water? If 7.6 will go for 20, how many grams will be in 100? Very simple. It's just your comparison like this. Now, 7.6 will dissolve in what? 20 grams of water, right? So S will dissolve in 100 grams. That's how simple that calculation is. So, you do your cross multiply. S is what? 7.6 times 100 over 20. So, that's your 0, and this is your what? Your 5. Or, you can just multiply this, and that will give you what? You know, you can do it this way, let me do it in a more simple way for you. So, let's just say, this 0 will cancel this 0, and 10 times 7.6, that's 76, right? 2 is 76, that's what? That's 38, right? So that's 38 grams per 100 grams of water. Do you understand? 38 grams will now dissolve in 100 grams of water. That's the answer to that. Okay? Now the next question. A certificate cube of saturated solution, alright, of sodium chloride at 30 degrees Celsius give on careful evaporation 3.9 grams of solute. So the amount of solute is 3.9 grams in a solvent of what? 10 centimeter cube. Do you understand that? So calculate the solubility of sodium chloride. I see that. So you are looking for the solubility of sodium chloride in grams per dm then mole per dm. Okay? So let's start with gram per dm, right? So gram per dm. Now, all we need to do is we say solubility in gram per dm is simply the mass in grams, okay, over the volume in dm. That's just what it is, okay? So what is the mass in grams? 3.9 divided by what is the volume in dm. The volume is 10, then divide by 1000, okay? So when you do that mathematics, you are going to have 1000 over 10. You can see, it's a very simple math. That's what? 39 grams per what? dm. Can you see that? 390 grams per dm. It's a very simple mathematics. I hope you understand that. Okay, let's do the one for, this is A, right? So let's do B. The one for mole per dm. Now, when you talk of mole per dm, this is in gram per dm. All you need to do is divide this by the molar mass. That will now be mole per dm because mole is mass over molar mass. So if this is mass in gram per dm, divide by the molar mass and you have your mole per dm. So what is the molar mass of sodium chloride? So for sodium chloride, you have what? 23 plus 35.5. Alright, sodium is 23, chlorine is 35.5. So what would that be? That will give you what? 58.5. 58.5 grams per mole. So now to divide this by the molar mass, 58.5 grams per mole. That will be what? Solubility in what? In mole per dl will be what? 390 over 58.5. Okay? So you can do this with your calculator. So press your calculator, whatever you have, that will be your answer. Okay? So now I have 15.3 grams of sample of potassium granulate. 5 was required to make a saturated solution with 50 centimeters cube of water at 25 degrees Celsius. What is the solubility of the salt at that 25 degrees Celsius? So now this solubility, for you to see all this molar mass, that means they're going to be solubility in mole per dl, okay? The standard solubility. So solubility in mole per dl, the formula is mass over molar mass times what? The volume, no, times 1000 over the volume, alright, in cm3. That's the formula for standard solubility, okay? Alright, so what is the mass? What mass we got? We have what? 15.3 over molar mass of potassium chloride. So let's look at it. Potassium chloride 5. So let's say 39 plus 5.5 plus now 3 times 16. That will be 48. 48. What would that give you? 39, 35, that is 74.5. 74.5 plus 48. 74.5 plus 48. So that would give us what? 0.5 and 2 and 5. That would be 2, 1. So that would be what? 1, 2, 2.5. Okay? Now, 1 to 2.5 times what? 1000. Alright? Then the volume in what? 20 times that's 50. Okay? So what we have? This is 5 here 1, 5 here is how many? 20. So you can do your press your calculator and get your answer, okay? Alright, so when you say this time this divided by this, that will give you the perfect answer. I hope you have your calculator, right? So let's move to the next one. The next one we have what? 10 grams of CuSO4 was required to saturate 50 grams of water at 180 degrees Celsius. What is the solubility of the salt at 180 degrees Celsius? So this is also like this one. So we have 10 grams of CuSO4 required to saturate 50 grams of water. So the question is 50 grams of water. Alright, that is the volume of water. Volume of water or mass of water is what? 50 grams. Now 1 gram is equivalent to 1 centimeter cube. Please understand. So whenever they give you 1 gram, I expect to, convert it to volume. It will be 1 gram per 1 centimeter cube. 1 centimeter cube. So 50 grams is what? 50 centimeter cube automatically. So the solubility will be what? Mass over molar mass, right? Times 1000 over what? Volume in cm cube. Alright? So just like this one. So what we have? What is the mass? 10. Okay? Molar mass of CuSO4. CuSO4, that is what? Copper is 64 plus 32 plus another 64. 4 times 16 for oxygen, that's 64. So 64, 64. That will be 128. 128 plus 32. 128 plus 32. That's 0. So that should be 160, right? So 160 times 1000 over 50. I think this one by 50 is what is here. Okay? This 0 will cancel this 0 here. Okay? So 4 here is what? 4. Then this is 100. Both of them multiply is 100. So this is more like 100 over 16 times 5. Okay, 4 here is 4. 4 here is 55. 5 here, 1, 5 here, 5. So 45, that would be 1.8, right? 1.8. So I think we got this one. This one is much easier. 1.8 mole per meter cube. Take note. It is mole per meter cube. Alright, these are standard solubility. Mole per meter cube. 1.8 mole per meter cube. Okay? So the next one. Alright, so now you can see that, look at the disparity here. We have 63.5, but I was using 64. Okay, so if you want to rearrange it, I think you better do just use 63.5 and apply all these things with it. Use your calculator and you get your answer. Okay, so the last, I think we have one more. The last one, yeah. That's the point I want to get to. So the last one here, we said the solubility of potassium nitrate is exactly 1000 grams per 100 grams. Per 100, supposed to be per 1000. 1000 grams per 1500 grams per 1000 grams of water. Alright? So look at that. This is the solubility of potassium nitrate is exactly 1500 grams per 1000 grams of water at 83 degrees Celsius and 700 grams per 1000 grams of water at 40 degrees Celsius. Okay? Calculate the mass of potassium nitrate that will crystallize out of the solution if 155 grams of the saturated solution at 83 degrees Celsius is equal to 40 degrees Celsius. So they gave you the solubility at the standard solubility, which is what? They said solute, that's 1500 grams is dissolved in 1000 grams. Okay? That will give you a total of, this is solute plus solvent, right? So that will give you, when you add both of them, that will give you what? 2500 grams. That is standard. The next one is what? 700 per 1000. So the same thing, this is at 81, 83 degrees Celsius. So the next one is 700 grams per what? 1000 grams of water, right? That will give us what? That will give us 700 plus water, that's 1700 grams at what? 25 degrees Celsius. So now, look at this. Look at this. When this particular salt is cold, that is the temperature drops from 83 to 85. From 83 to 85. What are you expecting? So look at this. Look at this. If the temperature drops from 83 to 85, you have that what? This now, you know that the solute is what? What is the solute? The solute initially here is what? The amount of solute here is 1500 grams, okay? In 1000 grams of water for 85 degrees Celsius. That is the saturated 83 degrees Celsius. That's the saturated solution. Now, at 85 degrees Celsius, the saturated solution is now 700 grams per day. Both of them are saturated. So at this point it's saturated, at this point it's saturated. Alright? So it means that if this saturated solution was cooled down to 35 degrees Celsius, it means that it must become this. It must become 700 to 1000. Meaning the excess mass, this one was 1500. Once it's cooled down to 25, this 1500 must what? Crystallize out. Only 700 will remain in the solution. So the remaining excess will be crystallized out, become crystal, won't be inside the solution. Why? Because it has been cooled down. So that excess will be 1500 minus 700. Are you getting it? Right? So that will give us what? 800. Isn't that? I don't know if you got that. Right? Okay. Let's do it like this. Let's do it with the solution. Now look at this. This is the solution, right? Now, by the time the solution is cooled down to 35 degrees Celsius, it's going to give you this, right? So, the excess will be 25 degrees, 2,500 minus what? 1,700. And that will give you what? That will give you, it's still going to give you 800. It's still going to give you 800 grams, right? So there's no matter the way you do it, they're still going to get the same thing. So what I'm talking about, what we are saying is that 2,500 gram of potassium thiochlorate, we what crystallize out 800, right? It will crystallize out 800 grams, okay? So this mass, 155 grams of potassium thiochlorate, if cooled from 83 degrees Celsius to 85 degrees Celsius without crystallize out X. You understand? If this one that was given as standard 2,500 grams of the solution gave us excess or crystallize out 800 grams, then 155 grams of potassium thiochlorate without crystallize X. Then you do your cross multiply. Your X is now what? 1,500 times what? 800 all over 2,500. So this. Sorry, 155, sorry, not 1,500. So this is actually this, alright? 5 years 5, 5 years 3, 5 years 1. We have 5. So, you understand? So, let's multiply this. 1 times 8, that's 8, 24. So, we have 248 over 5. So, 248 over 5. 248 over 5, that would be what? That would be 4. That would be 4, 8, sorry, 49.6. 49.6. Alright, 49.6 grams. I hope you understand that. Or you use your calculator and get the accurate calculation, okay? So, what you have to do is understanding on how to do this calculation now. Thank you. Alright?